Hey everybody, this is Mr. Beckstrom. I wanted to look at another example from section 5.5. This is similar to number 26. I want to look at one involving some trig functions here. It says use a change of variables or the table to evaluate the following definite integral. So we have the definite integral from pi over 4 to pi over 3 of negative sine of x over the cosine squared of x dx. So once again, we're looking for something that we can substitute in for u, that when we find the derivative of it, it is also there, or a multiple of it is there. Something that's there times a constant. So remember, we can always pull constants outside of the integrand. And the tricky thing here with trig functions is that when we see it in this form here, like the cosine squared of x, that's really just shorthand notation for the cosine of x quantity squared. And really we have to kind of look at it like that in a lot of these cases because for me it just kind of helps me visualize what it really means. So looking at it like that, I know that if I were to let u equal to the cosine of x, then the derivative of the cosine of x is equal to the negative sine of x. And the negative sine of x is sitting right there. So that'd be a great choice. Now, if I were to let the derivative u be like the negative sine of x, well, the derivative of the sine of x is the cosine of x, so the derivative of the negative sine of x would be the negative cosine of x. And we do have a cosine of x in here, but we have two of them. So that would be an issue dealing with the other one. So we couldn't really go the other direction here. We can only go this one direction and kind of deal with it in that way. So that's what I'm going to do here. So I'm going to let u equal to the cosine of x, and then kind of dealing with a power rule here for the integration. All right, so I'm going to let u equal to the cosine of x, and that means my du, my derivative of u, is equal to the negative sine of x, which is just sitting right in there nicely for me, dx. All right. And then I'm going to go ahead and let's just go ahead and rewrite this integrand, or this integral here, in a nice way so I can see how this substitution really goes. So I'm going to write it as sine of x times the cosine of x quantity to the negative 2 dx, right? So this is what it looks like if I were to write that like that and then bring it up to the top here. So let's go ahead and do or substitute in our limits of integration into the u world as well, because that's going to help us. So the bottom one, if I put a pi over 4 in here for, so this is the bottom one. If I put a pi over 4 in here for x, the cosine of pi over 4 is the root 2 over 2. And the top one here, I probably should have put it in the other direction. And the top one here for the pi over 3, put in a pi over 3. The cosine of pi over 3 is 1/2. So u equal to 1/2. So if I do that, then I don't have to actually substitute back in later. So making all my substitutions, including my limits of integration, I'm going to go from root 2 over 2 to 1/2. So I'm totally in the u world now. All right, so negative sine of x dx is all just equal to du. So I'm going to put the du there. So that's all taken care of. And the cosine of x is equal to u to the negative 2. U to the negative 2. All right, so we've gotten totally out of x's and totally into u's, including our limits of integration. So we're just going to apply the power rule for antiderivatives here. So this is just going to end up being what? Add 1. So that's -1, and then divide by -1. So we're going to end up getting negative u to the -1. And that we're going to evaluate that from square root of 2 over 2 all the way up to 1/2. So it should look something like this. So this is going to be -1 over u, evaluated from those. Square root of 2 over 2 to 1/2. All right, so this is, let's see, negative. We'll start with remember the upper limit. So what's -1 over 1/2? That's just going to be -2. And then we'll have a minus a negative, so that'll end up being plus 1 over square root of 2 over 2 is just the inverse of that, right? So just 2 over root 2. So that's just going to be plus 2 over root 2. And that is technically the correct answer. If you want to play around with that a little bit, combine it, get the radical out of the denominator, you can do that as well. But that's it. That's it. So if you have any questions, let me know. But hope you have a great week. Thanks.